Welcome to Section 6, Technology Supporting Scope Management and Change Orders. Click Begin to get started. Technology platforms that support the standardization and automation of scope management bring numerous benefits to built environment projects. These so-called Project Management Information Systems, or PMIs, offer time and cost-saving features such as electronic documentation management, transparent communication flows, and easily accessible information. Notification systems are linked to email or mobile applications, and open integration allows seamless data flow to other technology tools and management systems. In this section, you will gain a deeper understanding of how technologies can be used to support scope and change order management, the advantages of using technology to manage scope and change orders, best practices for using these technologies, and how to identify when and where in the project lifecycle you should implement them. Let's get started. Click Next. The built environment industry's reliance on legacy processes and old ways of working often results in inefficiencies. However, the industry has made some positive changes in this regard. Recent statistical analyses estimate that approximately $3.1 billion was invested in U.S.-based construction technology startups in 2018, a huge increase in comparison to the approximately $713 million invested in 2017. This growth in construction tech startups, as well as the refinement of existing solutions delivered to the industry, has led to increased experimentation and adoption. The built environment industry has been slow to embrace technological change. However, digitization is providing a catalyst for the industry to reassess business models and ways of working. Some of the recent technological innovations that have positively impacted the industry are listed here. The benefits of these technologies are numerous and are poised to transform the built environment industry, especially in the case of mega projects. Project managers, engineers, architects, and owner organizations can each benefit from technology adoption by eliminating, automating, and streamlining activities and providing better visibility on the project, thereby allowing more time to manage project risks and to deliver project outcomes. A common gap often requiring extensive manual effort is the collation of data needed to make informed and timely decisions. Technology enables an integrated way to deliver accurate data. This allows you to analyze potential change and its impact on the cost, schedule, and scope across the project lifecycle. By digitizing, built environment project teams can transform their ways of working and optimize scope management. These benefits include improved data collection through integration, timely insights to accelerate decision-making, a standardized process, automation, and speed and agility for approvals. Let's take a look at an example. Network Rail, the organization that owns and manages the railway infrastructure in the United Kingdom, is using drones to survey the land and geography around existing rail infrastructure. The gathered data is used to improve track maintenance projects, increase fieldwork efficiency, and provide health and safety benefits, such as reducing the need to work at height. You can leverage several new technologies to support scope development, scope control, and the change order management process. Some of these are shown on your screen. BIM is a software that generates digital representations of the physical and functional characteristics of a building. Features like 3D visualization help all project stakeholders to understand the scope of the project. Because it provides more accurate project information and data, you can make more informed decisions throughout design, construction, and operation. BIM should be adopted early in the front-end planning phase of projects to create visualizations, giving the client the opportunity to critically assess whether the current plans meet the performance outcomes and requirements. BIM is also useful for assessing scope changes raised on built environment projects by allowing project team members to update the model to reflect requested changes. These changes should also be evaluated in the model, provided it is supported by the software. Using BIM in a collaborative way on projects reduces the number and frequency of change orders. BIM is already a project requirement in certain industries, the UK public sector being one such example. Click the link to download a PDF that provides more details on the cost benefits and advancements in BIM. The use of unmanned aerial vehicle systems, or UAVs, or drones in the built environment industry is in its infancy, so industry professionals are still experimenting with the technology. Drones are equipped with sensors, reality capturing technology such as laser scanners, radio frequency identification readers, or RFID, and high optic cameras, all of which can be managed remotely using mobile phones or tablets. Drones have several unique capabilities which enable efficient and effective data capturing on projects. They are suitable for visual inspections, surveys, and data collection in indoor and outdoor scenarios. For surveying activities, drones can help a project team ascertain if the terrain is suitable for the proposed project. Their ability to gather information on high-risk areas where workers may have difficulty or be at risk is a major benefit. Data captured from drones, such as photos, videos, and imagery, can support organizations when scoping out projects and provide valuable information on project progress. Data analytics refers to the process of generating meaningful insights from raw data. Built environment projects and organizations generate a wealth of data over time. Data analytics technology uses data on the performance of past projects to help you monitor the performance and progress of your current one. Still, adoption of analytics in built environment projects has been slow, mainly because of the variability of projects in the industry. However, as data analytics have improved, they are able to identify useful similarities between projects of different types. Data analytics can be used from the project outset when the client organizations are making investment decisions or greenlighting feasibility studies. Some of the data on similar past projects that you can leverage include contractual arrangements used, project delivery method, number of change orders, cost of change orders, technology used, extent of scope development, timelines, and budget. Viability of skilled labor and economic factors are also incorporated to assess the probability of the project delivering upon its desired outcomes. Further, machine learning algorithms identify trends or highlight relationships between project factors and project success. Virtual reality, or VR, and augmented reality, or AR, have many applications on built environment projects. Click on each for a brief definition. With VR and AR, clients and project teams can immerse themselves in the project at the earliest stages. Since the client can virtually walk through and explore the facility beforehand, you can refine scope based on their input into the designed facility. This means less changes being raised towards the end of the design stage or in the construction stage. The later a change occurs, the more costly it tends to be. It provides similar benefits to contractors and different trades, who can review the designs in an interactive manner. This enhances their understanding of the project scope and reduces the number of errors, changes, and rework. Ultimately, the knowledge gap between clients and contractors is narrowed, ensuring everyone is on the same page. As a real-world example, VR was used on a medical center project in the U.S. state of Alabama. The design firm on the project created 3D models of the facility to let clients and end users walk around the medical wards. This allowed the stakeholders to move freely around the facility and interact with the environment to ensure the project, when ultimately constructed, was well positioned to meet the business's needs. Using technology for scope and change order management brings multiple benefits to built environment projects. Click on each icon to learn more about each benefit. Technology will not deliver value if it is not aligned with the project's strategy and goals. Further, it must be integrated into the project management process and practices in order to be effective. Organizations and professionals need to implement technology across 3 pillars: technology, people, and processes. All 3 need to be astutely integrated and managed. Ability, or lack thereof, of team members to adequately adopt and integrate a new technology will determine the value it brings to a project. A lack of adoption will lead to unrealized benefits. Technology adoption best practices are shown on your screen. Click on each icon to learn more. Before being digitally implemented, all processes and work being transferred to a digital solution should be reviewed for process improvements. To achieve maximum value from the technology solution, organizations and professionals should streamline the processes by eliminating waste steps. Inefficient digital processes will not generate the desired productivity improvements on projects. Focus on technology solutions that will support your project teams in solving a problem or inefficiency. Technology adoption requires capital investment, so it is important to be prudent with decisions. Selecting the appropriate technology will alleviate the resistance to change by professionals. When rolling out new technology solutions, focus on the value it adds to the project team members' work. This will help alleviate dump and replace syndrome. A mix of different technology platforms is often required to deliver a built environment project. When reviewing a technology solution, it is important to understand how it will interact with other platforms. Data must securely flow from one platform to another. As predictive analytics, machine learning, and artificial intelligence solutions increasingly take hold, this is paramount. Predictive models are only as valuable as the data that flows into them. Selecting and implementing integrable solutions will provide the data flow on projects, allowing project leaders to make more informed decisions. Real-time data and analytics brings true value to projects, while dispersed technology solutions result in information scraping, rekeying, compiling, reporting, and similar waste. As the built environment industry uses more technology, cybersecurity risks such as hacking and data theft are on the rise. Projects are generating vast amounts of highly sensitive data on building models, designs, drawings, and payment processing. Just as security protects office spaces and building sites, security measures need to be applied to data management. Since security breaches can lead to a regulatory fine or loss of reputation, organizations need adequate cybersecurity protocols and strategies in place. Implementing new technology solutions is challenging, not just for built environment organizations, but in all industries. Effective communication underpins any successful change management initiative. Best practices can increase the success rate of technology adoption on built environment projects, ensuring fulfillment of the desired value. When adopting technology solutions, organizations and professionals need to focus on the 7 best practices shown on your screen. Click on each icon to learn more. Successful implementation and adoption of technology depends on senior leadership. It starts with selecting the technology that best aligns with a project's short and long-term strategy. Leaders need to be pragmatic and clever with the allocation of capital investments in technology. Due diligence needs to be carried out on all possible solutions. Soliciting broad input from skilled professionals to site workers increases the chances of successful technology uptake and adoption. Change agents are employees of the organization or project team members who act as champions for the new technology. Change agents are flexible, open to challenges, and embrace change rather than resist it. These take an active role in using the technology on the project and clearly communicating the benefits to their colleagues. They support their colleagues in adopting the technology and act as the frontline support for any questions, queries, or issues. Selecting change agents that are experienced and respected amongst peers will help facilitate smooth technology adoption. It is important to set up goals and objectives paired with frequent reporting related to technology adoption progress. Regular reporting can help inform stakeholders of rollout progress and if any issues or resistance are being encountered. Reporting progress to the wider project generates and maintains interest in the technology. Team members will remain interested while looking out for any new developments. When goals, objectives, and milestones are met, they should be celebrated project-wide, as this helps recognize and reward individuals who have played an active part in its adoption. Implementing new technology in organizations or on projects doesn't happen overnight. Realistic timeframes need to be created for full rollout and adoption. In built environment projects, this might be done over the course of a project. Project team members may be resistant to change if the time frame is deemed unachievable. A clear adoption plan supported by change agents is vital to success. Communication around the new technology and its adoption is critical. A communication plan and strategy should be developed, identifying the key project and organization stakeholders. The strategy should emphasize the benefits the solution will bring to the project, team members, and project stakeholders. Quantifiable benefits are an excellent mechanism to portray the advantages the technology will bring. For example, the adoption of BIM on projects will reduce conflicts across disciplines on projects, potentially leading to reductions in change orders raised. The key elements of a communication strategy, as detailed in previous sections, is shown on your screen. Please take a moment to review them. The built environment industry has different competency levels when it comes to technical acumen or IT. When investing in technology, leaders need to think about the training requirements for their employees. Investing in training programs not only upskills the workforce, but increases the probability of adoption. Without training, the technology will encounter resistance. New technology will result in behavior and process changes in organizations and on projects. Leaders will need to spend extra time on learning the new technology and adopting their processes. Extra demand placed on team members in relation to technology adoption will have a negative outcome. Team members need to be provided with a stress-free environment and adequate time to master the solution. Therefore, managers and leaders should not demand that project team members hit their existing timelines while at the same time learning a new technology. A pragmatic approach to workload and scheduling needs to be adopted. Let's take a moment to see what you've learned. You have now completed Technology Supporting Scope Management and Change Orders. In the next section, you will have a chance to review all that you have learned so far in this course. See you there.